Hey folks, it's me, Miss Rogers, and here we are talking about properties of rectangles. This is our number 2 quadrilateral that we're going to talk about. First one we talked about was parallelograms. And remember, let's recap what parallelograms had. They had opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles are supplementary, means they add up to 180. And the diagonals bisect each other. So everything that a parallelogram has, rectangles will have. Plus these other two things. Rectangles have 4 right angles. They have 4 right angles. And their diagonals will be congruent. Diagonals are congruent. So not only do they bisect each other, they are congruent. So let's talk about some math with these. Okay. I'm going to zoom in on number 1. So number 1, so we know that from a parallelogram that opposite sides are congruent. So PQ and SR are congruent. So I'm going to label this one 24. And PS and QR are the same size, same shape. So this one is 10. Do I know anything else? Well, I could do Pythagorean theorem and find the length of PR, because I have 10 and 24 as my legs. So 10 squared plus 24 squared. Find my calculator. Let's see here. Turn it sideways here. 10 squared plus 24 squared gives me 676. Then I'm going to square root that. Square root, where's the square root? There it is. Oops, there that. Square root 676, I get 26. So PR equals 26. And since I know that PR and SQ are equal, because it says that the diagonals are congruent, I can also say that SQ is also 26. Okay. That means that PT is 13, TR is 13, ST is 13, and TQ is 13. How did I get that number? I divided this by 2 because of the bisector. It is bisected. Now let's answer the questions. QR is 10. SR is 24. SQ is 26. PR is 26. QT is 13. There you go. That one wasn't too bad. All right. Let's try number 3. This one has angles in it. Remember, when you're dealing with angles, you have to look at the middle, and the other two tell you the direction to go. So let's fill in what we know about angles. KJL and JLM are congruent by alternate interior angles. So that was 27. Let's see, what else can we find? Let's see. I'm thinking. Let's see here. This is congruent to this, so this angle has to equal this angle, so this one is 27. That means this angle and angle M, KML, is also 27 degrees. I need to find N, so I'm going to take 27 plus 27. Well, let's see here. 27 plus 27, that's 24. 7 plus 27, that equals 54. Subtract 180, I get 126. So this angle is 126. So this angle is 126. Subtract that from 180. So 54 and 54 equals, 27, that would be 54. Right there, and this one would be 54. Is that correct? Yes. (27) minus 90, so 90 minus 27. Where am I getting the 90 from? This angle is a 90-degree angle. This is 63. And this side is congruent to this side, so this one is 63. These are congruent over here, so this is 63, and this is 63. A lot of numbers in there. So let's figure out what we have. MJK. MJK. That whole angle is 90 degrees. That's given to us because we know that all parallelograms, all rectangles have 90-degree angles. MJL. MJL. We found that to be 63 degrees. JLK. JLK. That's this one right here. 63 degrees. KML. KML is 27. MNL. M to the middle and then down to L. 126. We used a lot in that one. We used alternate interior angles. We used complementary angles. So we used a lot of stuff that we have used before. Exterior angles, if you wanted to do that, 27, 27 gave you 54. Okay. Let's look at number 5. So DB, this whole side right here, whole diagonal, equals 42. I'm going to put a box on that. AD, this one right here, is 26. Angle of DAE, DAE is 52 degrees. And I've got to find all the stuff over here on the right. How can I figure this out? Well, first I know that my alternate interior angles, I know that this angle right here is 52 degrees. I know that BC is 26 degrees. 26, not degrees, it's 26. I can figure out this side right here by using cosine of 52 equals 26 over x. If I wanted to. You see that? Here's my right angle. Cosine 52 degrees equals 26 over, no, not it. It's not cosine, it's tangent. Come on, Miss Rogers. Learn your ratios. Tangent of 52 is 26 over x. So that would mean you flip the x in the 26, 50, tangent 52, so x equals 26 divided by a tangent of 52 degrees. Go to our little calculator. Come on, there we go. So we're going to do 26 divided by tangent of 52 at 20.3. So x equals 20.3. So AB is 20.3. See, 52, that would be 48 right here. See, 20.3 right there. This one is 42. I forgot about it. I could do the Pythagorean theorem and check it out. (42 squared minus 26 squared). Take the square root of that. Let's see if we get 20.3. Square root, oops, clear. Square root 42 square minus 26 square. Nope, that's not what I get. I get 32.9. Let me see if I do it. 42 square minus 26 square. Get 1088. Square root, oops, clear it. Square root 1088. I got something totally different. It said 20.3. I want to pause this. Okay, folks. So I rewrote this problem. I messed up originally. I had it this switched. So I rewrote it. Tan 52 equals x over 26 because it is opposite, which was x, over adjacent. Opposite, which was x over adjacent. And so you get 26 times tangent of 52, which gives you about 33. And you can check it by doing 42 squared minus 26 squared. Take the square root of it, and you get about 33. So it checks out, okay? So now we have that. Let's see if we can answer our questions. AC is 42. Let me zoom out here. AC equals 42. EB is 42 divided by 2, which is 21. BC is 26. AB, we're going to say 33. Angle ADC is 90. ADC. ABD. ABD. We didn't write that one. But it is the same. See, here's our congruent sides. It is the same as 48 degrees. Don't forget your degree sign. BCA. BCA is 52. DEC. DEC. We didn't figure that one out. So let's pause a minute. We're going to pause. Let's see here. Okay, folks, so what I did, I took and did the alternate interior angles and found that this angle was 48, and it's congruent to the other angle over here, which is 48. So 48 and 48 make 96. And I'm going to subtract 180 and 96. That's a 4. 17 minus 9 is 84. So this angle E, DEC, is 84 degrees. All right? So that's a little bit of the math. We're going to pause right here and let you catch up with that.